Pomodoro Joe here with some bonus material for LeetCode problem 100, same tree. We just finished up building out a recursive algorithm for solving this problem. The problem statement basically says you're given two trees, two binary trees, and you need to see if they are the same in terms of the nodes holding the same values at the same locations. And yeah, we built out this recursive algorithm. Let's see if we can find a way to do this in a non-recursive way. So we'll go ahead and delete all that. And now we're going to figure out, can we do this iteratively? So anytime I have a solution that was recursive and I want to make it iterative, I think I can use a stack. That's what I go to. Say, okay, I can use a stack. So we're going to have some stack, and that's just going to be a list in this case. Now, what do we put on the stack? Well, let's put our nodes P and Q. I'm putting them as a tuple here. So we're going to put P and Q on our stack. And then we're going to say, while we have a stack, so that's essentially just saying, while the stack is not empty, then we will pop our node off the stack, or our pair of nodes off the stack. So we'll call this, what do we call this? Nodes. So we'll do stack.pop. And it doesn't really matter if we pop the front or the back. In this case, I'll pop the front. So we have two nodes. Now we're going to check, are these the same? Now we basically jump into a similar algorithm to our recursive algorithm. So if nodes 0, so that's going to be P in this case, is none, and nodes 1 is none. So if both of these are none, then we will continue. So in this, at this point, we could return true in our recursive algorithm, but because we have an iterative solution, we can't just return true here. Okay, so both nodes are none, we can continue. All right, so if node 1, or we'll say node 0 is none, and node 1, or actually we're going to say or node 1 is none. So in this case, we're just saying, if both of them are none, then we'll just keep going. If only one of them is none, well, in that case, we know that this is not a match, and we can return false. Okay, so if we made it past this point, we need to check if node 0's value matches node 1 value. Or in this case, we want to say, does it not match node 1's value? So if their values don't match, then we're going to return false, because we know we don't have a matching tree. At this point, we need to check to see if their right nodes match and their left nodes match, or the entire right branch versus the entire left branch, or I should say both right branches match or both left branches match. So in that case, we'll just create two new pairs to push on our stack. So the first one will be stack append. And so our first pair will be node 0 left and node 1 left. And we'll do the same thing for the right. So we're just going to package up the nodes right and P's right and Q's right. And so we'll match the left and the left and the right and the right, and push those on the stack, and then the stack will keep going. If we ever reach a point in this algorithm where we don't have matching nodes, we will return false. At the very end, if we made it through all of the nodes and none of them threw out a false, then we can return true. So this is definitely more complicated in terms of thinking about than our recursive algorithm, but it generally will give us better performance. Ooh, I got something wrong here. Node is not defined. Nodes. I probably did the same thing down here, didn't I? Yep. Everywhere. See if I can fix this up. Salvage some of this. Okay, did I get all of them? Hopefully I did. Yep, that works. Let's submit that and see if it gives us any performance gains. Generally, it will, not guaranteed. Oh, that gave us significant performance improvement, both in runtime and memory. So this one beats 93% of other solutions in terms of runtime, and it beats 98% of other solutions in terms of memory. So going with the recursive algorithm, it's straightforward. Once you get used to recursion, at least, it's more intuitive. Going with the iterative solution, however, is generally going to be faster because you don't incur the overhead of the recursive calls. That overhead is both a runtime overhead and a memory overhead. So using this iterative approach with a stack oftentimes will give you performance gains both in runtime and in memory. Okay, well, I hope you enjoyed that. Hope you learned something. Hope you can go out and write some better code.